Hello and welcome. In this video, we are going to dive into the world of numbers in Python. We'll explore the different types of numbers you can use and how to work with them. Specifically, we'll be looking at integers, floats, and complex numbers, giving you a solid foundation for numerical operations in Python. Python has three main numerical types: integers, floats, and complex numbers. Integers are whole numbers which can be positive, negative, or zero without any decimal points. For example, -50 and 100 are all integers. Next, we have floats or floating point numbers. These are numbers that contain decimal points, such as 3.14, -0.5, or 2.0. Lastly, complex numbers are numbers with a real and imaginary part. They are less commonly used, but are very important in scientific and engineering applications. Let's take a closer look at integers in Python. Integers are whole numbers, meaning they don't have any decimal points. They can be positive, negative, or zero. A key feature of Python integers is that they have unlimited precision, which means they can represent very large numbers without losing accuracy. Python also supports representing integers in different bases, such as base 2, also known as binary, base 8 or octal, and base 16 or hexadecimal. Integers are very memory efficient for storing whole numbers, making them a great choice for many programming tasks. Let's see how we can perform operations with integers in Python. First, we assign the value 10 to the variable a, and the value 3 to the variable b. Now let's perform some basic arithmetic operations. Addition, a plus b which equals 13. Subtraction, a minus b which equals 7. Multiplication, a times b which equals 30. Division, a divided by b, which equals approximately 3.333. Floor division, a double/b, which performs integer division, resulting in 3. Modulo, a %b, which returns the remainder of the division, resulting in 1. Exponent, a double asterisk b, which raises a to the power of b, resulting in 1000. Now let's explore floating point numbers in Python. Floating point numbers, or floats, represent real numbers using a decimal point. They are represented internally using the IEEE 754 standard, which defines how floating point numbers are stored and manipulated in computers. Floats have limited precision, typically storing 15 to 17 significant digits. This means that floating point numbers can have small rounding errors in calculations. You can also express floats using scientific notation, for example, 3.14e10. Floats are commonly used for representing decimal values and are the result of division operations. Let's see how we can perform operations with floats in Python. First, we assign the value 3.14 to the variable x, and the value 2.5 to the variable y. Now let's perform some basic arithmetic operations. Addition x plus y, which equals 5.64. Subtraction x minus y, which equals 0.64. Multiplication x times y, which equals 7.85. Division x divided by y, which equals 1.256. Exponent x double asterisk y, which raises x to the power of y, resulting in approximately 17.95. There are also built-in functions for floats. For example, we can use the round function to round x to one decimal place, resulting in 3.1. Let's discuss an important aspect of floating point numbers: precision. Due to how floats are stored in computers, they can sometimes exhibit precision errors. For example, if we add 0.1 and 0.2, the result is not exactly 0.3, but rather 0.3 followed by a bunch of zeros and then a 4. To fix this, there are a couple of ways to solve this. 1. We can use the round function to round the result to a specific number of decimal places. 2. We can use the decimal module to perform arithmetic with higher precision. Let's move on to complex numbers in Python. Complex numbers have a real part and an imaginary part, and are written in the form a plus bj, where j is the imaginary unit, and j squared equals -1. Complex numbers are a built-in type in Python, making it easy to work with them. They are commonly used in various fields, such as signal processing and physics. To access the real and imaginary parts of a complex number, we can use the .real and .imag attributes. Let's explore operations with complex numbers in Python. First, let's create some complex numbers. We can create complex numbers by typing the real part, plus the imaginary part with a j after it. Or we can use the complex function and pass the real and imaginary parts as arguments. Now let's perform some basic operations. Addition, z1 plus z2, results in 5 plus 9j. Subtraction, z1 minus z2, which results in 1 minus 1j. Multiplication, z1 times z2, results in -14 plus 23j. Division, z1 divided by z2, results in 0.62 plus 0.07j. To access the real and imaginary components, we can use .real and .imag. For example, z1.real will give us 3.0, and z1.imag will give us 4.0. Finally, let's look at how to convert between different number types in Python. To convert an integer to a float, we can use the float function. To convert a float to an integer, we can use the int function, which truncates the decimal part. To convert a number to a complex number, we can use the complex function, passing the real and imaginary parts as arguments. You can also convert a string to a number using the int function, but be careful because the string must represent a valid integer. When converting between types, keep in mind that converting from float to int will lose the decimal part, and converting complex numbers to real numbers is not directly possible without using the .real or .imag properties. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.